Hello everyone. I'm delighted to participate in the webinar competition organized by Anusandhan National Research Foundation in collaboration with IIT Mandi. Myself, Dr. Pratheepkumar, since 2022, I have been working as an assistant professor in the Department of Chemistry, School of Advanced Sciences, Vellore Institute of Technology, Vellore, Tamil Nadu, India. So initially, we have secured ANRF Startup Research Group with the duration of uh, 2 years. So we have been working on sustainable catalysis for CH1 functionalization and organic synthesis. So I'm happy to present one of our recently published work as part of ANRF funded project. The project entitled Blue LED driven synthesis of benzyl guanidine hybrids via radical cross coupling. In the introduction, guanidine is one of the important structural motif which is widely used for base as the organic synthesis, including asymmetric organic synthesis. So, some of the representative guanidine containing pharmaceutical molecule presented here. So, for example, finasteride it's used for the hypertension drug, and triple one as the synthetic sweetener. NC174 used as a antibacterial agent, HPDF used as a anti-HIV agent. So, in terms of methodology, in the literature, various methodology emphasized for the synthesis of guanidine, but however, several challenges associated, which includes a stoichiometric amount of desulfurization agents and also metals and other oxidant. So to overcome these challenges, so we came up with the mild Photoredox approach for the synthesis of broad spectrum of benzyl guanidines. So with using rose bengal as the catalyst, the blue LED for 440 nanometer and ethanol water as the solvent. This methodology also comes under the category of green matrices with atom economy 90% and E factor 4.02. So optimization of the reaction condition, we have screened photocatalysis and solvents, bases and the light source, and we screen other conditions such as under dark condition in the absence of rose bengal, even under argon atmosphere, under nitrogen atmospheres. So here in the rose bengal was promising comparison with other dyes and graphitic C3N4 and solvent ethanol water system was promising, and potassium carbonate was promising as a cheap organic base and also less toxic light source for 40 nanometer. So here under nitrogen atmosphere only 10 percentage product was observed, so indicates that molecular oxygen is essential for this transformation. So with the optimized reaction condition, we have developed the substrate scope. So here, the diverse array of secondary amines produced the desired benzyl guanidine with the potentially viable yields, and even product 3A was confirmed by single X-ray crystallography. So in the benzyl thiourea derivatives, also promising for this strategy, only the electron withdrawing group did not afford any desired product. So further, heterocyclic substrate scope of benzyl guanidine also explored. So thiophene was promising in this strategy with the diverse array of secondary amines such as piperazine derivatives, morpholine, and thiomorpholines. So in the case of furan, we did not observe any product. It may be oxidative decomposition with light. So in the post modification, we have achieved oxidative annulation via the CH bond activation step to achieve isoquinolinone embedded guanidine derivatives using ruthenium as the catalyst. Further, several control experiments were carried out. Some of the key strategy we are presenting here. So the first one, the benzyl thiourea under the standard condition, gave the fragmented intermediate. Further, it was confirmed by single X-ray crystallography. So using this one intermediate 1 and 2, we have carried out the standard reaction condition. It is giving the desired product in the viable yields. So here, the important radical scavenging studies were carried out with the help of tempo. So where the in the presence of standard condition, so the desired product was not observed. Instead, we have observed the tempo fused intermediate product in the ESI HRMS spectroscopy. Further, the intermediate one in the presence of blue LED in the radical scavenger tempo, it is giving the tempo fused imine type radical in the ESI HRMS spectra. So further, the sulfur dioxide, sulfate also was confirmed using lead acetate, so which further characterized. So again, light on-off experiment also was carried out. So here, light irradiation is essential. So in the absence of light, the desired product yield is diminished. So further, fluorescence quenching experiment was carried out with the rose bengal with varying concentration of intermediate 3. So here, intermediate 3 underwent effective quenching with rose bengal. So further, with the Sternwolmer plot, reductive quenching of rose bengal was observed. So further, cyclic voltammetry study of intermediate 3 and rose bengal was carried out. So here, in the intermediate 3, oxidative potential curve with a 0.68 electron volt was observed. In the case of Rose Bengal, reduction potential curve of Rose Bengal was observed. So from this, Rose Bengal can be able to oxidize intermediate 3 via a reductive quenching pathway. So with this control experiments, we have proposed the mechanism. So first step is the mum type rearrangement, 1,3 thioamide transfer. Further, in the presence of light, it gave the fragmented intermediate 1 and 2. So intermediate 2 underwent reaction with piperidine to give the intermediate 3. So here intermediate 3 underwent single electron transfer to produce intermediate 4 with the help of excited state photocatalyst. Further, it produced rose Bengal anion radical. So this rose Bengal anion radical underwent single electron transfer with molecular oxygen to produce a superoxide radical. Further regeneration of rose Bengal catalyst. So this superoxide reacts with intermediate 4 to form the intermediate 5. With the elimination of sulfate, it is forming alpha immunyl radical, and from the intermediate 1, imine radical. Further, radical cross coupling to produce intermediate 8. So upon hydrolysis, it's produced benzyl guanidine. So this work was published in the Chemical Communication, Royal Society of Chemistry. The work was carried out by the PhD student Krishna Rao Jairam Desai. So thank you for the opportunities, ANRF and IIT Mandi. Thank you.